Hey guys, hope everybody's doing well. I see a lot of people have been starting on the work already, and that's great. It's looking really good so far. I wanted to give you one other optional video. Some people were asking me a lot of questions about the special triangles part on the Khan Academy, and I just wanted to show you kind of what I consider the special triangles or the special angles and why they're important, why we use them. So this is going to be a quick video. It's going to be similar to some of the other ones, but another way of thinking about some stuff in case you're confused. So the three special triangles that we're going to use when we talk about the unit circle are these three right here. So we have a 45, 45, 90 triangle. All these are right triangles. So a 45, 45, 90, a 30, 60, 90, and then this is also a 30, 60, 90, except it's tilted in a different way. So our 60-degree angle is down here. And I'll show you why these are the three triangles that we want to use when we look at the unit circle. So I'm going to come over to the unit circle here, and I'm going to fill in the angles in radians first. So this first angle here is going to be pi over 6, and then we have pi over 4, and then pi over 3, and then this would be pi over 2. So remember that all the way around this circle, from here all the way around to here, is pi radians, right? And then if we go all the way around completely, all the way around the circle, we come back to here, and this is 2 pi radians. So this is, we call this 0 radians and also 2 pi radians right here at this point. These are both ways to describe this point because we go all the way around the circle and come back. So pi over 2 right here is halfway in between 0 and pi, so that should make sense. Pi over 3 is a third of the way between 0 and pi. Pi over 6 is a sixth of the way between 0 and pi. That's where I got these radians from. So I'm going to go around and finish out the unit circle here. So if this is pi over 2, now we're getting back to, this is going to be 2 pi over 3. So this is 2 thirds of the way from 0 to pi. This is going to be 3 pi over 4 right here. And then this is going to be 5 pi over 6. So we're 5/6 of the way from 0, or another way to think about it is we're 1/6 of the way away, 1/6 away from pi. So 6 pi over 6 would be the same thing as pi, so that's how we get to here. So this angle right here is going to be pi over 6. But if we're counting counterclockwise from the x-axis like we normally do with positive angles on the unit circle, it's going to go from 0 all the way around to 5 pi over 6. So let me keep filling this out real quick. So this is going to be 7 pi over 6. This is going to be 5 pi over 4. And you'll get more familiar with this as we go. I know it seems like I'm just filling this in from memory, and I am, but you'll basically memorize it without even trying the more you use it. Let's see, this will be 4 pi over 3. This would be 3 pi over 2. So now we're over, all of these fractions should be greater than 1 because we're over 1 pi. So now we're getting up above pi over 1. So now we got 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. This one right here is going to be, let me think, 5 pi over 3. This would be, let's see, 7 pi over 4. Yes. And then this last one right here is going to be 11 pi over 6. So remember, if we add pi over 6 to this angle right here, we're going to get back up to 2 pi. 12 pi over 6. 12 pi over 6 is the same thing as 2 pi. Okay, so we've got our angles filled in on the unit circle. These are all of the angles in radians. And so the reason that we use these triangles is because 45 degrees is the same thing as pi over 4 radians. And there's a couple videos on the Khan Academy talking about why that's the case. So if we converted this from radians to degrees, or degrees to radians, 45 degrees and pi over 4 radians are the same angle. And then here, 30 degrees is the same thing as pi over 6 radians. And 60 degrees is the same thing as pi over 3 radians. So that's the reason that we use these specific triangles, is because all of these angles correspond to the radian measures that we're looking at on the unit circle. And so the way that I use these reference triangles essentially is, let's start with the 30, 60, 90 triangle, where the 30-degree angle is in the bottom left corner here. So I'm going to use a green marker to try and illustrate this. So this, I usually think about it as placing this triangle in this position here. So I know that I've got a right triangle. I know that this angle is 30 degrees or pi over 6, so those are the same thing. And then I know that this angle up here has to be 60 degrees. And so using my SOHCAHTOA rules and the Pythagorean theorem, I can figure out that this this leg of the 30, 60, 90 triangle is 1/2, and this leg is square root of 3 over 2. And I can do that because I know that on the unit circle, the radius is always going to be 1. So since the radius of this circle is 1, I know that the hypotenuse of this reference triangle here has to be 1. And so if I know that the hypotenuse is 1 and I know these angles, I can use SOHCAHTOA. So for instance, let's say I wanted to find this opposite side right here. So I know that I could use the sine of pi over 6, which is this angle right here, this 30-degree angle, has to be equal to the opposite side over the hypotenuse. So the opposite side from this angle, we know it's 1/2, but I'm showing you why it's 1/2. So we're going to say that that's x. That's what we're solving for. And that's going to be over the hypotenuse, which we know is 1. So in other words, sine of pi over 6 is simply whatever the opposite side of this triangle is. And that's always going to be true because the hypotenuse is 1. So there's a couple videos already that you've watched that have shown you sort of how these side measures have been derived. The one on YouTube by Patrick JMT, that one's really good, that shows you each of these special angles. I just wanted to show you the way that I use them. So I'm not going to go through each one here, but those videos also show you exactly where these side measures come from. But sine of pi over 6, so if you don't believe me that that's 1/2, one way we can check it is we can just pull up a calculator right here. And let's see. We want to make sure we're in radian mode first, because I'm going to put my angle in radians. So I am in radian mode. That's how I check that. You may not have this calculator at home, but you probably have something similar, or you can use an online calculator. You just want to make sure you're in radian mode. And then I'll just do sine of, and then see the pi button is, y'all are sitting here watching, you know exactly where it is, and I don't. There it is. Okay. Sine of pi over 6 equals 0.5, which is 1/2. So that's where this 1/2 right here comes from. In this specific triangle with a hypotenuse of 1, the sine of the 30-degree angle, or the pi over 6 angle, is 1/2. So the reason I showed you all that, that's how we derive some of these side measures. Again, there's a video detailing how you get each of these side lengths. If you want to see that, that's on the YouTube video. But the reason that that's helpful is because that tells me the length of this side of this triangle is 1/2, and I also know, again, I would use cosine instead of sine here and do the same process to find the length of this leg, which is square root of 3 over 2. So that's helpful because I know now the coordinates of this point right here at pi over 6 is the x coordinate is square root of 3 over 2, or the cosine of pi over 6, and the y coordinate is 1/2, or the sine of pi over 6. What's helpful about these triangles, though, is that this triangle also fits over here, if you want to think about it like this. It also fits down here, whoops, and over here. So you can use this same triangle, these lengths right here. So the length of this side and this side and this side and this side and this side, all of these are going to be the same. So no matter if I'm at 5 pi over 6 7 pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6, or just pi over 6, all of these distances will be the same. Now the sign on them will be different. So for instance, over here, the square root of 3 over 2 length, the leg of this triangle over here is going to be negative. So this is the coordinates of this point. And again, there's some other YouTube videos that kind of go into more detail about this, but the coordinates of this point at 5 pi over 6 would actually be, sorry, let me get a different color. This would be the negative square root of 3 over 2 comma positive 1/2. So the x value is negative because we're in the negative x direction. If this is the xy axis, then we're in the negatives. And the x direction and the y direction we're positive. So that's why we have positive 1/2 over here. But I use that triangle to find all of these different, distances because they're always going to be the same because all of these angles are equivalent. So similarly, let me just show you a couple other uses for this. And again, if you already understood how we were getting this stuff before, maybe this isn't exactly helpful, but I think I just wanted to show you a different way. This is how I think about the unit circle when I'm trying to figure out different values at different angles. But again, so I can do the same thing with these other two triangles. So this special triangle right here, the 45, 45, 90, and remember 45 is the same thing as pi over 4, so I can draw that triangle right in here. So I know that whatever the length of the legs of this triangle are, square root of 2 over 2 and square root of 2 over 2, that's going to be true here, here, and here, but it's also going to be true if I draw my special right triangle down to 7 pi over 4. It's going to be true if I draw it down to 5 pi over 4. All of the pi over 4 angles have the same dimensions. Again, the signs are going to be different. So here in the first quadrant, we have square root of 2 over 2 and square root of 2 over 2. Over here, for instance, this is going to be negative square root of 2 over 2 because we're in the negatives now in the y direction. And this is also going to be negative square root of 2 over 2. So if you were looking at the coordinates for for 5 pi over 4 right here, the coordinates for that one would be negative square root of 2 over 2 comma negative square root of 2 over 2, because now we're in the negative direction in the x direction and in the y direction. So both of our x and y coordinates are going to be negative. Okay, and lastly, I think you're getting the idea now. Let me just show you why I use the other one. And again, so this is really only two triangles because the green triangle and the yellow triangle over there are the same triangle. One's just tilted on its side and one's standing straight up. So it's really only two special triangles that we're thinking about, but I drew all three because we use the upright version here for the pi over 3 angles. So the last one that I'll draw is all of these angles at some increment of pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All of these triangles are also the same as this triangle over here. So all of the dimensions are also going to be the same, just like the others. So this is going to be square root of 3 over 2. The way I remember it is the long side is always square root of 3 over 2, and the short side is always 1/2. So if you think about it, square root of 3 over 2 is larger than 1/2. The square root of 3 is like a little bit bigger than 1, but not quite 2. And so if it's bigger than 1 and the denominators are the same, then the square root of 3 over 2 has to be bigger than 1/2. So anyways, the long side's always going to be the square root of 3 over 2, but again, it's going to be the same on all of these triangles, except the signs might change. So for instance, this is going to be negative 1/2, this is going to be negative square root of 3 over 2, and this is going to be negative square root of 3 over 2. So if I wanted to find the coordinates at 5 pi over 4, and I'm about to run out of time here on my screen recording, that's going to be positive 1/2 and negative square root of 3 over 2. All right, I hope that's helpful. If you have other questions, I'm going to be doing a review session later this week, and I'll try and answer those as much as I can, but feel free to send me emails or message me on Google Classroom if you have other questions. Thanks, y'all.